Hello and welcome to day 6 of Unit 5. Today we're going to be revisiting rectilinear motion and using definite and indefinite integrals to look at some interesting ideas involving acceleration, velocity, and position of a particle moving along a single axis. Now I think that that's the key to this lesson, is understanding that this particle is moving along a single axis. So its position, x of t, measures a distance. Let's say this axis looks like this, and we'll call that 0. That's the origin. Then this function x of t measures the distance from that either positively or negatively. Okay. So this would be at some time, say time 1, x of t1 equals a positive value, let's call it pi. That means that the particle is pi away from the origin. And over the interval from 0 to t1, the particle has moved a total of pi units. Okay. So keeping that in mind, and that position is merely the integral of velocity, which is the integral of acceleration. And all of this works in reverse, that acceleration is the derivative of velocity, which is the derivative of position. Now there's also this idea of displacement versus distance. Well, given a velocity versus time graph, that maybe looks something like that, this would represent, or the area here would represent negative distance traveled because the velocity is negative. This would represent, or this area would represent positive distance traveled as velocity is positive there. Now, if these two values, or if those two areas were equal, then the displacement from t equals 0 to t equals 2, I just made that number up 2. If these areas are equal, the displacement from t equals 0 to t equals 2 should be 0. Because I travel in the negative direction some distance, and then in the positive direction the exact same distance. And displacement is just a measure of the difference between where I start and where I end. Okay? Now, if I wanted to know the total distance traveled, I would want to add the absolute value of this, or the negative value of it. So the total distance traveled over the interval from 0 to 2 would be the sum of these two positive areas. All right, so that being said, let's get started. Okay, let's see. The first example was fairly simple. Particle moves along an s-axis. Find the position function of the particle if acceleration is equal to t squared minus 3t plus 1. Okay. And I know that velocity of 0 is 0 and position of 0 is 3. So my initial velocity is 0 and my initial position is, I made a mistake, it's 4. Okay. All right, so to get to position given acceleration, I've got to integrate first to get the velocity and then integrate again to get the position. So let's start. The integral of acceleration or the antiderivative here, would be t cubed over 3 minus 3 over 2 t squared plus t plus c. Now, I got to solve for that constant of integration. But I know that the initial velocity is 0. So when I plug in 0 to t, I should get out 0. Well, if I plug 0 into t here, here, and here, this is just going to become c. And the initial velocity is 0. So c must be 0. So my actual velocity function is t cubed over 3 minus 3 over 2 t squared plus t. All right, now let's get the position. So we're going to integrate velocity. Please don't forget the dt. That tells me what you're taking the integral with respect to. And without it, your integral is not right. So the integral here would be t to the 4th over 12 minus 3t cubed over 6 plus t squared over 2 plus c. Now I got to solve for c, but I was given the initial position. So when t is 0, I'm going to get 0 minus 0 plus c equals 4. So c's got to be 4. So the answer here, the equation for position is t to the 4th over 12 minus 1/2 t cubed plus t squared over 2 plus 4. Okay. Okay, so now we're going to step things up a little bit. Now, I'm given the velocity function, and I'm asked to find the displacement and the total distance traveled by the particle over the interval pi over 2 to 2 pi. Now, I do want to briefly talk about why this total change theorem works. If I'm given a velocity time graph, and let's say I had some nice nifty function that looks like this, well, the area underneath that curve from A to B can be determined by dividing the interval into smaller and smaller subintervals, and then determining, and let's do a midpoint here because we don't do midpoints enough. Okay, so there's my estimation of the area under the curve, which is represented by this Riemann sum, this midpoint Riemann sum, and the areas of these things have dimensions of dt, and the heights are v of t's. Okay. Well, v of t is actually a rate, right? It's the change in position over the change in time, right? Velocity is dx dt. It's the derivative of the position function with respect to time. So the area of that rectangle has units that are actually just the change in position. So the area under the curve of a rate represents the total change of whatever the rate was measuring. So integrating velocity will give me the total change in time. The area underneath represents distance. Okay. Now, we're going to do displacement first. Displacement's easy because I can just straight up integrate. The integral of cosine t is sine t, and I'm evaluating from pi over 2 to 2 pi, which is sine of 2 pi is 0 minus the sine of pi over 2, which is 1. So my displacement is -1. -1 units. So that means wherever I started, when I stopped 1 unit behind where I started. 1 unit in the negative direction. Now distance is a little trickier. I have to know something about the function. And the thing I have to know about the function is where it crosses the x-axis. Now let's think about cosine. Cosine starts here at 1. It starts here at 1. It goes down like this and back up. Now, pi over 2 is right here. And I like this problem because it's easy to find the x-intercepts, because it's a function that you're familiar with, cosine of t. And this over here, this is 2 pi. So when I integrated, I found this negative area and added it to this positive area and got -1. And you can tell that there's more negative area than there is positive area. So it's reasonable that I expect a negative answer for displacement. But for distance, I want the total distance. For distance is always positive. So I want to know how much area this is. How far in the negative direction did I go? What was the magnitude of that? Well, to get that, I just want to make it positive area. Knowing that when I integrate from pi over 2 to 3 pi over 2, I'll get negative area. I can anticipate that and make it negative. So negative pi over 2 to 3 pi over 2, the integral cosine t dt, plus the integral from 3 pi over 2 to 2 pi of cosine t dt will give me the total distance traveled. Without that negative sign, this is going to be a -2. With it, it becomes positive. So I get my total distance to be 3. Now, just interesting factoid here, as long as the magnitude or the amplitude of this function, of the sine and cosine function is 1, any one of these dips like that, full dip, has an area of 2. Okay, then that's just something nice to know. Still, if I were to ask you to do something like this, you would at least need to set up the integral, but I don't really have to solve it now because I know that this is -2 and that this is +1 and that's +1. All right, think about traveling around a circle. What's your displacement from start, t equals 0 to 2 pi? Your displacement is 0, but your total distance will be 4. just an addendum to what I had just said, because I realized that it might be confusing when I said that your distance around the circle was 4. That's because in this case, cosine is representing your velocity, not position. So I did not mean for you to calculate the circumference around the circle. I was merely using the circle as an analogy when looking at the cosine function as velocity, right? Displacement, if you were to go all the way around the circle, if you were to integrate from 0 to 2 pi, that would be going all the way around the circle, would be 0, because you're ending where you stopped. Okay. So merely a commentary on the symmetry of the trig functions cosine and sine. Okay. All right, so in this example, example 3, same question. What's the total displacement and what's the total distance over the interval from 1 to 5? Only difference is I'm given the acceleration. Now I can't take the second integral. Okay, I'm gonna have to find the integral of a of t. Okay, I know that the initial velocity is 0. Okay. The integral will give me velocity, which is t squared over 2 minus 2t, plus c, but c is going to be 0 since the initial velocity is 0, and this is a polynomial. Okay. All right. So if that's my velocity, now I can integrate from 1 to 5 of t squared over 2 minus 2t dt to find my displacement, my displacement. Okay. So this will be t cubed over 6 minus t squared, evaluated from 1 to 5, and that's going to be 5 cubed is 125 over 6, right? Minus 5 squared is 25, minus 1/6 minus 1. Okay, so let's see, 125 minus 1 is 124, 6, 1, or negative 25 minus a negative 1 is a minus 24. And this, for me, works as an answer, as does it on the AP test. Okay, that's fine. There's no need to go through that and simplify that. Okay, now distance, it's a little bit trickier because this may or may not cross the x-axis. And if it crosses the x-axis, then there may or may not be some negative distance that I'm calculating. And when I do total distance, I want to make all that negative distance positive. So the first thing I'm going to have to do is determine whether that crosses the x-axis. And to do that, I set it equal to 0. Okay. So we get 4t equals t squared. So t squared minus 4t equals 0. I don't like the way I did that. Let's just multiply through by 2 here. Okay, I get t squared minus 4t. Now that factors into t minus 4. So t equals 0 or 4. T is going to, or the velocity function is going to cross the x-axis at 0 and 4. 4 happens to be in our interval. Okay, so let's do this. Let's calculate the integral from 1 to 4 of velocity, t minus 2 dt. Oops, t squared over 2 minus 2 t. Okay, and let's calculate the integral from 4 to 5 of t squared minus 2t, t squared over 2. Okay. Let's get these two values. One of them might come out to be negative, and if it does, we're going to take the absolute value of it. So essentially what I want to do is that if any of those come out to be negative, we want to make them positive. Okay? So, see, we're going to get the same thing as we did up here. So t cubed over 6 minus t squared evaluated from 1 to 4. And t cubed over 6 minus t squared evaluated from 1 to 4. Okay. So this is going to end up being, let's see, I wish I had saved some room here. So let's put this over here. Distance continued. Okay, so we'll have a 4 cubed over 6. Let's see, 4 cubed, 4 cubed, or 4, no, 4, yeah, 4 cubed is 64 over 6 minus 4 squared is 16. Minus 1 cubed over 6 minus 1. So 1/6 minus 1. Here, I messed up my bounds there. So 5 is going to be 125 over 6 minus 25 minus, plug in a 4, is 64 over 6 minus 16. All right, so let's see. That's 63 over 6. Negative 16 minus a negative 1 is negative 15. And let's see. Negative, or 125 minus 64 over 6 is let's see, that's 161 over 6. 25 minus 16, or excuse me, negative 25 minus a negative 16 is going to be negative 9. All right, now let's see. This one's going to be the one that's negative, because 63 over 6 is less than 15. So, what I'm going to do to not have to worry about simplifying this is, I know that's going to be the negative one. Okay? So my final answer is going to be negative 63 over 6 plus 15 plus 61 over 6 minus 9. And that's a fine answer. Now that does simplify a little bit better, because that's negative 63 plus 61 over 6 is 4 over 6. Is negative 2 over 6, and 15 minus 9 is 6. So I have that as my final answer. Now, knowing if I had a calculator, knowing that this crossed the x-axis at 4 would allow me to just type in the integral of the absolute value of t squared over 2 minus 2t dt from 1 to 5, and that will give me the same answer. But without a calculator, I have to check for where the velocity crosses the x-axis, because I want to take into the account that I might get negative area, which in this context represents negative distance. In doing total distance, I want to add positive distance. So.